Hydrogen. You've probably heard it talked about a lot, right? The clean fuel of the future. But it's not quite that simple. Turns out there's a whole color-coded world of hydrogen out there. And, spoiler alert, not all of it is actually clean. So in this explainer, we're going to crack that code and figure out what hydrogen's real promise is. Let's get into it.
Here's what we're covering. First, we'll look at that clean promise, why everyone's so excited. Then we'll dive into the super important color code. After that, we'll check out the EU's massive bet on hydrogen, tackle the challenge of actually getting it where it needs to go, and finally, see why writing a clear rulebook is maybe the most crucial step of all.
All right, part one. So why all the hype? What is it about hydrogen that has so much potential? Let's get right to the heart of it.
Just stop and think about that for a second. A fuel that could power our factories, our trucks, our ships, and the only thing that comes out the other end is pure, clean water. No smoke, no soot, no CO2. That right there, that's the dream. That's the fundamental promise of hydrogen. And you don't even have to be a chemist to see why. On the left, you've got your standard fossil fuel, natural gas. When you burn it, you get energy, sure, but you also get that CO2. But look at the right. With hydrogen, it just combines with oxygen. And poof, you get energy and water. H2O. That simple difference, getting rid of the C for carbon, is the entire game changer. But, and this is a huge but, that beautiful, clean reaction is only half the story. It turns out the real climate impact depends completely on how the hydrogen was made in the first place. This is where we need to crack the color code. First up, we've got the hero of the story, green hydrogen. The idea here is simple. You take water, H2O, and you zap it with electricity to split it back into hydrogen and oxygen. The absolutely critical part, though, is where that electricity comes from. For it to be green, it has to be from renewable sources like wind or solar. That way, the whole process is clean from start to finish. Next on the list is blue hydrogen. Now, this one is a bit of a bridge technology. You're still making it from natural gas, which does create CO2. But you use special tech to capture most of that CO2 before it gets into the atmosphere, and then you store it, usually deep underground. So it's not totally emission-free, but it's considered a low-carbon option. And that brings us to gray hydrogen. Now, this is made the exact same way as blue, from natural gas. The difference? No carbon capture. None. All of the CO2 that's created during the process just goes straight up into the air. It's the cheapest and most common way we make hydrogen today, but it's also a major polluter. Okay, so now that you know the colors, here's the reality check, and this number is pretty wild. Today, right now, more than 90% of the hydrogen we produce is gray hydrogen. So despite all the exciting talk about a clean energy future, we are starting from a place that is overwhelmingly not clean. And that is the central challenge we've got to solve. So how do we make that massive shift from gray to green? Well, let's take a look at the European Union, because they are making a huge continent-wide bet that clean hydrogen is the answer. And when I say huge, I mean it. The EU's goal is to be using 20 million tons of clean hydrogen every year by 2030. Now, just for some perspective, their current use is around 8 million tons, and almost all of that is gray. So this isn't a small step, it's a monumental leap. The plan is to produce 10 million tons themselves and import another 10. It's a massive undertaking.
This chart really shows you the strategy. See the big gray area for fossil gas? The plan is to shrink that year by year. And look what's filling the gap. Those green and blue bars, that's green hydrogen and biomethane. The really important thing to see here is that this is a direct replacement plan. It's not about adding more energy on top. It's about systematically phasing out fossil fuels.
Okay, so you've got this ambitious plan to make millions of tons of green hydrogen. Fantastic. But then you run smack into the next giant problem. How in the world do you get it from, say, a huge offshore wind farm to a steel mill hundreds of miles inland? Well, this is what we're starting with. This map shows the current dedicated hydrogen pipelines in Europe. It's pretty tiny, just about 1,600 kilometers, all packed into one little industrial area. When you compare that to the millions of kilometers of natural gas pipelines we have, it's clear we're pretty much starting from scratch. But here's the vision for the future. The plan is to create a nearly 58,000-kilometer hydrogen backbone stretching across the entire continent by 2040. And here's the really clever part. They're not going to build it all from the ground up.
The idea is to repurpose about 60% of the existing natural gas pipelines. That move alone makes the whole project way cheaper and way faster. So when you're moving all this hydrogen, you've really got two main options. For moving huge volumes across land, pipelines are by far the most cost-effective. That's why they're the core of the plan. But for those long-distance imports we talked about, you'll likely need to use ships. The catch there is you have to turn the hydrogen into a liquid, which takes a ton of energy, and then turn it back into a gas at the other end.
So we have the ambition. We have an infrastructure plan, but none of this gets built. Not one pipe gets laid without the final, absolutely critical piece of the puzzle, a clear, unified set of rules.
This quote really says it all. I mean, think about it. If you're going to invest billions of dollars to build this stuff, you need to have confidence. Everyone needs to agree on what clean hydrogen actually is. You need to know how it's certified and that the hydrogen you're getting from another country meets the same standards. Without that, nobody's going to write the checks. And that's exactly what the EU has been doing. They're actually creating legal definitions. They're saying, look, renewable hydrogen officially means it's made from renewable electricity. And they've created another bucket for low-carbon hydrogen, which has to prove it's at least 70% cleaner than fossil fuels. By creating this common language, they're giving the market the certainty it needs to finally start building.
So there you have it, the incredible promise of a fuel that only emits water, the messy challenge of a color code that separates the truly clean from the dirty, and a colossal plan to build an entirely new energy system from the ground up. The ambition is clear, the plans are written, but the journey from today's gray reality to a green future, well, that's one of the biggest challenges of our time. The only real question left is, can we pull it off?